Hello everyone, this is Jason from the Maipu Communication. Today I will doing the MLAG the lab training. What is MLAG? MLAG is a mechanism to regulate cross-device link aggregation, which gathers one device and two other paired devices form a dual-active system. MLAG is used for several dual access, which can be used. The availability is increased from the link level to the device level. Normally, the MLAG is used to connect to the server. MLAG. What is the advantage of the MLAG? First, it is explaining the network. MLAG is understood as a virtualization technology. It will deal into the access of the two devices, logically virtualized into one device. And the second one is the high reliability. So from here on the topology, there has 1, 2, 3, 4 topology. In the topology 1, we can say there have two devices work as the MLAG. So the server connect to the network by using the load balance. The traffic will go to the two paths at the same time. In the topology 2, if the peer link is done, to available the loop come here. So the MLAG will shut down the other interface of the slave device. So this traffic will go to the primary device, go to the network. And on the third, if any link, for example, the link down on the master device or link down on the slave device, the traffic will automatically fail over to another device. And the fourth, if any device is fault, so the traffic will automatically go to another device. MLAG application system MAC address. MLAG system MAC as a common system MAC address for two devices. MLAG system MAC is used in protocol where paired loads need to prevent DHDs uniform. MLAG system MAC address it is automatically generated by the system, and it also can be manually configured. The system automatically generated MLAG MAC address is executed with the domain ID. The MLAG system MAC address is 001789500008 and the domain ID. The domain ID as for the MLAG, the domain ID range is from 1 to 555. So we return the 255 MAC address from 0001789500B to 000178950109 as the MLAG system ID. The MLAG define. The MLAG, the full name is Multi-Chassis Integration Group. MLAG domain. Currently, the Maipu support the two devices to do the MLAG. So these two devices should belong to the same domain ID. This is similar like the spanning tree. It should belong to the same region name. And the MLAG load. In the MLAG parent load, there is one load for 0 is master, and the other load 0 is slave. And for every load it has a private. The default private is 100. The lowest private will become the master device. For example, one node private is 100. Another node private is 20. So the 20 device will become the master device. The peer link. The peer link, the direct connection aggregation link between the MLAG parent node, which used to interact with MLAG protocol spectre and transmitter the traffic data. The Kepler detector between MLAG parent nodes, which is carried out through the layer 3 link. The function of MLAG is to judge whether the peer link is still alive after the peer link fails. MLAG port indicates the aggregation port group across devices between DHD and MLAG dual active system. MLAG member port indicates the member port of the aggregation group across devices between DHD and MLAG dual active system. Mark address learning to act as a single logic switch. Both switches must synchronize their MAC address tables. Address learned on dual connected ports are added to the corresponding ports on the other switches. Address learned on all single connected ports are added to the ISL on the other switch. Address learning is disabled on the ISL. So from here, we have a MLAG lab. These two devices work as the MLAG 1. This is MLAG 2. So they have switches is DHD1. And this one is DHD2. So on the topology, the MLAG 1 and MLAG 2 will connect to the DHD1 and the DHD2. The DHD1 and the DHD2 is configure the link aggregation. And on the test, the DHD1 will doing the ping to the DHD2, and we will doing the failover testing, like we shut down any link of this one or any link to check the failover. And also we also need to check if the link aggregation, if the Kepler is down, what will happen? And also if the peer link is down, what will happen? So from here, this is the configuration. If we do the configuration, first we need to create the link aggregation 10, link aggregation 20. And also these two devices is used as the to connect to the different DHD. So from here we do the config on the switch. From here, the MLAG 1 will do the configurations like this. For link aggregation 1, the mode is LSAP. For link aggregation 10 and link aggregation 20 is connect to the DHD. So its also mode is LSAP. On the switch, we configure the different VLAN. The VLAN 111 is used for management. We use to test the failover to check the MAC address and ARP. So from here, you can see the MLAG domain. Because the MLAG 1 and the MLAG 2 should belong to the same domain, so the domain ID is the same. The domain range is from 1 to 255. So the range is from 1 to 155. Okay. The load ID 1. So from the load, the raw private default is 100. The range is 1 to 254. And from just now, we set the MAC address. The system marker is generated by the automatically. So from here, the MAC address is 00B because from here my domain ID is 1. So the MAC address is B. If I configure the domain ID is 10, so the MAC address will from A and 10. Okay. So because from here we have one IP address used for the cap level. So we use the 00/20 used for the cap level interface. On the map switch, we can use the layer 2 link by using the low switch port to become the layer 3 interface. So we configure the IP address under the GI 0/20. Okay. So for the management IP address, from here we configure the VLAN 111 used for management to test the failover and to test the MLAG feature. After this one finished, we also can see the MLAG 2. For the MLAG 2, we also configure the VLAN 100, 200, 111, the 3 VLAN. And for the link regression 1, link regression 10, and link regression 20, we configure this interface as the switch port trunk and trunk around all. And for the link regression 1, they use it as the MLAG peer link. And link regression 10 and link regression 20 used for the DHD. So we need to configure the MLAG group 10. So switch 1 is also MLAG group 10. So this one is 10. This one is 10. This one is 20. So this means the DHD1. The DHD1 is connect to the different device. So from here you can see GI01 and GI02. GI01 is connect to the MLAG 1. GI02 is connect to MLAG 2. So from here we can see the integration is up. So and from here we can show interface integration term. We can say the bandwidth is 2G because every link is 1G. So for the DHD1 and the DHD2, we only configure the integration term and configure the VLAN and make the integration term work as the trunk mode and trunk VLAN and trunk allowed VLAN all. And for the DHD is also the same. We configure is integration 20 work as integration 20 because here is LACP mode. So we configure the mode is active. And the IP address is 111 to 114. So from here, we can come here to see the MLAG status. We can by use the command show MLAG brief. By show the MLAG brief, we can see the domain ID is 1, and this device is master. And MLAG 2 is the slave. So just now we said they select the master and all slave is based on his role ID. So we can show MLAG load. By show the load, we can say the master the load ID is 1, the property is 50, and for the slave load ID is 2, the property is 20. So the load state property will become the master device. And also from here we can see the system MAC address. We come to see here show MLAG load. MLAG load for the MLAG 2, the load ID is 2, priority is 20. So this one is come to the slave device. Just now we set his ARP table and a MAC address table. We are doing the SYN. So from here we try to pin the DHD1 and the DHD2. Pin DHD1 is pin OK. DHD2 is also OK. So we show the ARP table. From the ARP table, we can say, hey, MLAG pin the DHD1 is come from the integration 10. Pin the DHD2 is come from the integration 20. Okay, so we show the MAC address table. So learning this one from the DHD2 is from integration 20. DHD1 is come from the integration 10. Okay, so we come here, pin 111.1.3, pin 111.111.4. Show ARP is also the same from the integration 10, integration 20. Show MAC address. So this one is also the same. So this means for these two devices, his MAC address table and ARP table is the same. Now if we shut down any interface, we show integration groups here. We just take the integration group 10 for example. I have only one interface come to here. So we come to shut down this interface. I do the shutdown, okay? So from here, we show the integration group 10. So this one is detached. This means the integration 10 is done. But from here, we do the pin 111.1.3. So it's also can pin. So from here, we show the ARP table. This also can say the integration 10 is also here. So this means if any link is done, actually the traffic will go to the peer link, come to the MLAG2. From the MLAG2, he go to the integration 10, come to the DHD1. Now we come to test the failover. From the DHD1, we pin the DHD2 continuous pin. The latest is okay. So we will do the failover by shut down any interface. So first we will shut down which one? We will shut down the integration 1, okay? We shut down from here because we pin is from here to come here. So here we will go to the integration 10. So we shut down this link. So the traffic will go to here, come to here. After we shut down, we check the pin. The pin has low packet drop. So we stop here, low packet drop. We show the integration group. So we can see the 001 is done. Actually, the traffic is go to the 002. So we also continuous pin, and we're doing the recovery of 001. No shutdown. We come here to say if the link is recovered, there has any packet drop or not. So from this pin, we can know there has low packet drop when we're doing the shutdown or low shutdown. So it means any link is down it has low pack drop. Okay, so on the topology, we can say if we shut down any link, the traffic is okay. So we shut down another link, 0, 2. We shut down another link means we shut down this DHD1 to DHD to the MLAG1. We shut down here, and from here we do the P is also okay. So if we doing the switch one, make the switch one is device issue. So for example, we're doing the reboot of this one to check what's the result. The traffic is okay or not okay. So the ping is a continuous ping. So we're doing the reboot. Okay, so now this switch is doing the reload. So from here, you can see they have 2 pack drop. After the 2 pack drop, the traffic is okay. So from the console, we can see the device is still under the loading after reload. So also we can come to the DHD2. So we show the link glitch. From here, we also can say this one interface is done because now the switch has loaded up. So for the MLAG, before the device reboot, we can say some information from here, like the show MLAG graph. We can say the interface, which interface is up, which turn is up. This level, show MLAG load, show MLAG group. From the MLAG group, you can see the peer device, the stations. So from here, I do the show the MLAG. So from here, we can say remote interface is done. MLAG 20 is also done because the MLAG 10 and MLAG 20 is used for the DHD connection. So we can say this interface is done. So my local is up, remote is down. If any link is down, so you can say there has unredirected. And later, when the device is come up, we can doing the shut down the peer link. If shut down the peer link, we can say what will happen when the peer link is done. Because the MLAG, these two devices has configured the keep level. If the MLAG peer link is down, so the interface will be shut down. Now we show the MLAG group. So you can see the ping is still okay. Okay, so after we reboot the MLAG1, now we can say the MLAG1 is become the slave, MLAG2 become the master, because as reboot. So it means previously the MLAG tool is already become the master. So I come up. So it will not doing the relaxing to make the network much more stable. Okay. So now if I will shut down, the pure link. So link regression 1. The link regression 1 is used for pure link. So I will shut down the pure link. Okay. If the pure link is done, so from here you can see the pure connection is broken. So we show MLAG graph, show interface switch port graph. So you can see the 001 is error disabled. The pure link is done. Based on the keep level, he will shut down the other interface to make sure it has no loop. So if we load shut down the interface, show interface GI0/1, the status error disabled. So you can see it's shut down by the MLAG. So MLAG graph. So that's why it's become the master alone. And for the device, show MLAG graph. You can see he is slave suspended. Show interface switch graph. We can see 0, G01, G02 is still up. But from the switch, we can see this one is disabled. 0, 2, no shutdown. It's shut down, so it cannot. Okay. So if we come to the integration 1, we do the load shutdown. Okay, so it's already recovered. So MLAG show integration groups. Integration 1, integration 2. So we come to here. Integration 1 is detached. Okay, so the MLAG lab is finished. So on the phase 2, I will set up the MLAG with the MSTP environment.